Hi friends, in this video series, we are developing and deploying AI agents to different services from GCP, AWS and Azure. In the previous videos, we have developed an AI agent, gave it access to customers' orders database. And then we wrap the agent in a FastAPI application so that the client apps can make HTTP request to our agent to inquire about the status of their orders. And then we containerized the application using Docker and then deployed it to GCP Cloud Run. Today, we will deploy our agent to another application called GCP Cloud Functions. All right, so deploying it to Cloud Functions is a lot more simpler, but it also has its own limitations, right? So these functions are supposed to be a single purpose functions, meaning we can do some lightweight works using Cloud Functions. Unlike Cloud Run, where we can take full-fledged applications, containerize them, and run those jobs for a longer time. Okay. Whereas Cloud Functions, these are in general very short-lived, and we can invoke them via HTTP request, these pops up messages, and also any changes to the cloud storage buckets. Okay. So it's a lot easier to use these functions, but they comes with their own limitations. But in our case, our agent has only single purpose, which is informing the customers about the status of their order. So we can still use Cloud Functions. But if you have more complex agent architecture, probably Cloud Run or some other service is a better choice over Cloud Functions. All right, since it is for learning purpose, let's deploy to Cloud Functions as well. All right. Okay, now we need to make some changes to our application. As it is not going to be a FastAPI application, the first thing we need to do is we need to remove all FastAPI related stuff from our function. Okay, and also because this is supposed to be a special cloud function, we import this library called Functions Framework from GCP. All right, and then as you can see from here, we used to have the FastAPI app initialization, and then we have developed two endpoints, right? One for health checkup, the second one for the actual chart. So we remove all that FastAPI code. That's change number one. And the second one, to our entry point or our cloud function, we need to decorate it with this functions framework. And we also indicate that we are going to make HTTP request to this function. All right. And then there are a couple of minor changes on how we handle the input data as well as the output. Okay. So now we have this request variable as an input. So this is how we access the user message. Okay. Using the JSON. All right. And similarly, we JSONify the output. We are using Flask for that, but it's not a Flask application per se. Okay. All right. So two main changes. One, we need to completely remove all the FastAPI dependency. It's not going to be a web server or endpoints, etc. And the second one, our entry point function, we need to decorate with functions framework, and we need to indicate we will be making HTTP request. And then there are a couple of minor tweaks on how we handle the input data as well as output data within our cloud function. Okay. So that's our main file. And then to the requirement file, simply add this functions framework, which is from GCP. All right. So ideally, those are the only two files required. And as I mentioned before, copying the .env file is not a good idea. Usually, we would store all the secrets on our some sort of cloud secret stores service, and then we can access them using some cloud SDK, right? To keep it simple, we are still copying across a .env file. Now ignore all other things like this main2, main3 and app. We will require only the main.py, the requirements and .env file. Now once we have that, since we are deploying it as a function, we are good to go. We don't need to do anything more. In a previous video, we have discussed some of these commands. First, we authenticate. This will open up your Google account in a browser, authenticate it, and then you need to configure some variables if you haven't done so, but this is a one-time thing. Okay. All right. And then to deploy the function, we just need to run this command. Okay. So gcloud, its functions we are deploying, and we give it a name. So we are calling it AI agent function, and then region, the runtime Python 3.10, the source, the current working directory. Now the good thing about functions is the source code can live on a GitHub repo. So whenever we make changes and push changes to the Git repo, we can automatically trigger the function deployment so that we can have the new version of the function. Okay, the old version still remain. We will have the new version. Then we can also configure how we want to split the traffic between the old version and the new versions of the functions. Okay, the entry point app, which we have in our main file. So the entry point is this app. All right. And then we will be triggering the function via HTTP request. As I mentioned, the most common methods are this mostly used for internal triggering rather than triggering this function from outside. Okay, so maybe the pubs up changes to cloud storage files, uploading a new file, things like that, renaming, etc. Right? So there are two versions. Use the latest version, which is Gen 2. We give it some memory. As I said, these are small functions, so even 256 MB should be fine. Allow unauthenticated, that's just for the testing purpose. All right, so just take this command and run it from your terminal from where you authenticated. So I have already done it. So here it is. Okay, so this is how the logs looks like. And if everything goes successful, if everything goes well, we should see an endpoint like this. Okay, since we made it into HTTP endpoint, right? So the region name, the project, so US Central region, the project name Sri_NANA, sorry, -NANA, it's cloudfunctions.net, and then our actual function name AIAgent fun. Okay, that's how it looks like. And then if you go back to the console, so actually under the hood, GCP uses the cloud build to deploy the functions also. So you can check the cloud build logs here. This is how they look like, cloud build logs. And all our code, etc., is still stored in artifacts registry. Here we have the artifact registry. So gcr.io, that's for the containerized application, so where the containers are stored. GCF-artifacts, this is where our cloud functions are stored. So if we go here, all right, so I have different functions. If I look at this function, which is what we just deployed, here we have two different versions of the functions. So as I mentioned, we can have the source code in a Git repo, and whenever we commit new changes to the Git repo, we will have the new version of the function. Now, in case if you delete the function from Cloud Functions, your artifacts still remain here. So you can come here and select one, and I think let me click on one. Since we have all our artifacts available here, we can deploy the function to Cloud Run. So Cloud Functions used to be a separate service, but GCP has merged into Cloud Run. So within Cloud Run, we have container services, we have function services. Okay, we will see in a second. And we can deploy to these Kubernetes engines as well as compute engines. But with these two, we would have to do a lot more work, right? Whereas other services are managed by mostly by GCP. All right, and then let's go to our Cloud Run. So here we have the Cloud Run. As I mentioned, Cloud Functions used to be under a separate service, but now they have merged. So if you look at the deployment type, this is where you see. So these two applications, these are containerized applications, whereas this one, which is what we just deployed, it's a Cloud Function. Okay, so let's go here, Cloud Function. So the first thing, since we have enabled allow unauthenticated, but sometimes it may take some time. So in that case, go to networking and choose all. So we can invoke this function from anywhere from the internet. But as I mentioned before, unlike Cloud Run, which is a general purpose and can be invoked from everywhere, Cloud Functions are in general are for internal invocations in response to some events within the cloud, like pubs up, cloud storage, account changes, etc. Right? All right. Now, if you have used AWS Lambda functions before, it's very similar. So in the source, you will actually see all the source code. Now, since our repo here has some unnecessary file, they are copied across. But as I mentioned, all we need is our main file, which contains the function, the requirements file, and then .env file. Okay. So this app.py commands main 2, main 3, these are not required. All right. So we can do some inline code editing. Here we can change, update the code. For example, we can maybe play with the prompt, and we can deploy a new version from here itself quite easily. Okay. All right. So if you go to revisions, okay, leave the page, revision. So here we have two versions of the Cloud Function. Let's say the prompt is different in this case. Now we can split the traffic between these two versions, similar to Cloud Run, and find out which one works best to use in the production. All right, so here is our endpoint. Now, again, as I mentioned, this is not a web server or like a FastAPI application where we can have multiple endpoints. Okay, it's a single function. That's the main distinction. Okay, keep that in mind. So copy it, and let's go to Postman. So here we have it again, the region, the project name cloudfunctions.net and actual function name AIAgent function. Now we will not have docs like we have for FastAPI application, and also we do not have any endpoints like chat, maybe root, etc., right? So it's a single function. All right, since we enabled HTTP, so we can still make a HTTP request. So we are just asking, hey, what's the status of order with tracking ID 1007? And it came back answering something. Here is the customer name. This is when it is ordered. Expected delivery is September 3rd, 2025. Okay. All right. If you find this content helpful, please support and share in your network. That's all for this video. And in the next video, we will deploy the same application to App Engine, which is more for these web application, full-fledged web applications. We can deploy much more complex applications to App Engine. Thank you very much.